Pretty clear.
Yeah, very clear. Cool. Okay, hi guys, this is Anupama, and today I'm going to talk about another design pattern, that is strategy pattern. Okay, so let me start this evening by saying good evening and thank you for joining. And this session is going to be a 2 hours long session, and I'll be very happy to answer your questions if you guys have any. Okay, so feel free to interrupt me anytime and ask your questions, clarifications, and doubts. So let's get started. Okay, so today we are going to okay. So I think today we're going to look into few of these things. What is the problem with, complex, if it is not there, what are the problems you're going to face with our strategy, a bit of introduction, basics, and then, we'll end up with the conclusion. Mm, that's about it. And then before jumping into what exactly a strategy pattern is, let's take a quick look at few basic things. Okay. So before going to the design pattern, I'm going to talk about three things. That is the basics of OOPS and quick briefing on solid principles. And then what is exactly the definition of a design pattern. Okay. Mm, does anyone have any doubts so far? I see someone is talking, I guess. Mm, no? Okay, good. Going ahead, the first thing is the basics of OOPS. What exactly is an OOPS and everything? Uh, so would anyone like to take a guess what exactly is an OOPS? Anyone interested? Mm, okay, let's go. So to put it into simple terms, it's a system based on the concept of objects that contains, a data, model, and method. So all these things. So the basic definition of like the acronym means that object-oriented programming system. And the primary purpose of object-oriented programming is to increase the flexibility and the immutability of program. So there's always a way that you can write in many different ways. It's just the reason why we have all these principles or designs and all the things in place to meet the life of a programmer who's working, and also for the application and easy. So tomorrow if someone wants to make more enhancement or make it better in some other ways, it should be easy and it should not be taking that much time. So that's that is a major goal and aim why we exactly have all these things. So the basic definitions, so the oops is completely like it starts with an object, and with object you have something called class, inheritance, polymorphism, abstraction, and encapsulation. So these are the basic terminologies that go around with oops. So I'll just give you a one-liner definition for all of this. So first is object. It's a bundle of data, and it's a of data and its behavior. So it have two characteristics, that is the states and the behavior. A class is a template for objects, okay, and an object is an instance of class, is what I can simply to put in. So, and then inheritance, probably the best way of defining is, the process by which one class can acquire the properties and functionalities of another is probably we can call inheritance. And we have many types of inheritance, which we are not going to look into it because primarily we are just having a quick glance. Okay, and then going to next, when the individual objects are created, right, they inherit all the variables and the methods from this class. So even in today's design pattern we're going to talk about of inheritance, and probably during the coding time I can probably show you a real-time example with code how exactly inheritance work in Python. Okay, so one more definition is probably what we can say is inheritance is a process of defining a new class based on the existing class by extending its common data methods and members. So going ahead, that's abstraction. Well, abstraction is a process where you show only the relevant data and hide the unnecessary details of an object from the user. So this is a very, very important part of this, the entire design patterns. You'll be encountering this in many different ways. Okay. So next going to is encapsulation. Well, it simply means that, binding the objects, the states, and the behavior together. Okay, that's the simplest way that we can say. If you're creating a class, you are doing an encapsulation. And last but not the least, the polymorphism. And again, we're going to look a closer look on polymorphism, inheritance and abstraction in today's design pattern. Well, polymorphism is an object-oriented programming feature that allows us to perform a single action in different ways. Okay, so there are two types of polymorphism, that is a static and dynamic, which is also called as method overloading and method overriding. So that's a very high level terminologies. So yeah, that's about oops, and let's quickly go to solid principles. Yes. So let's have a quick look at solid principles. So um, we have actually not just solid, we have multiple principles in our the entire software designing thing. But I think solid is something that each and every developer tries to follow, and most of the industry company, they also have all this thing in place. They give the trainings to the developer. It's good to have this thing in place. So I'll give you one liners for all this also. So basically, S stands for single responsibility principle. That basically means that a class should have only one responsibility. Furthermore, it should only have one reason to change. Okay, so we should never club more than one functionality into a one class, or you may even call a method. As you know, they should have only one thing. Their job is only one thing. It's not like multiple jobs is being performed via one method or via one class. So that's what the S stands for. Going ahead, O is called open close principle, and or it is also being called open for extension and close for modification. Simply put, a class should be open for extension but close for modifications. Okay. Uh, uh, is anyone saying something? Mm, okay, I'm not sure. Okay. Okay, so I was talking about open and close. So basically, this principle talks more about saying that we should never let any other class to change the basic things of one particular class. We should never allow anyone to modify the current class structure or the data model, whatever it is. Other classes can use the current class, but they cannot modify the existing things. So that is what it means. Open for extension, but close for modification. In doing so, we stop ourselves from modifying existing code and causing a potential new bug. So this is the whole aim of O. Next, going ahead, L. L stands for list curve substitution. Well, if class C is a subtype of class B, then we should be able to replace B with an A. The reason for that is because A is is a superclass and B is like a child class. So this behavior should be there within our program. Going ahead, I stands for interface segregation. Okay, and in interfacial segregation, it basically means that whenever we have a lot of interfaces, larger interfaces should be split into smaller ones. So by doing so, we can ensure that our implementation classes only need to be concerned about the methods that are interested in them. So I hope you guys basically know the definition of interface is that it will basically have the method name, but it will not have the body. Whoever is implementing the interface needs to write the body also. So if you have a larger interface, the problem with that is who is trying to extend it or implement it. While implementing it, there would be so many unused or not related to that class or functionality, but yet you need to write the methods for them. Even though you have to write dummy methods, but yet you need to write some of the code over there. So which is really a headache. So that's the reason it is better to split the larger interfaces. And always we have to remember that the segregation of interfaces should also be mostly based upon the functionality, so that for a longer time the code will be very much flexible and maintainable. Okay, so that's I. The last one is D. The D stands for dependency inversion. Okay, the principle of dependency inversion refers to the decoupling of software modules. So this way, instead of high level modules depending upon low levels, both will depend on abstraction. So D is something, I guess most of the large systems, they try to do this. We always try to decouple things so that we are not actually writing any sort of code which is tightly coupled and it might break in the future. Oh, okay, so that's about it. So I'll just wait for maybe a minute or so if anyone have any doubt so far on the basics.
Anupama, if I'm not wrong, Python doesn't support interfaces, right? So how
Uh,
does it done in Python? Yeah.
yeah, that's a really good question. Probably we'll be covering this as part of the coding, sir. Is that fine?
Yeah, makes sense.
Yeah,
Thanks.
you are actually correct that it doesn't have much of an interface, but still, we can have the abstraction facility in what do you call in Python, I guess, as far as I'm aware. You can have those at the rate abstract methods. I think Python 3 or something is also supporting.
Okay,
I
okay.
I read somewhere, I guess. Yeah.
Yeah,
So
I'm also not sure, but yeah.
we'll cover this as part of because today I'm planning to. I think I did wrote about. No, no, I didn't write my abstraction today, but that's fine. We'll cover as part of the coding. Okay. I'll talk about how we can have abstraction and everything in Python. Okay. Cool.
Yeah,
Any
sure,
other doubt,
thanks.
guys? Any so far? Mhm. Okay, let's go ahead and let's see what Wikipedia says about this question. That is, what is a design pattern? Does anyone wants to take a guess what exactly is a design pattern, and more importantly, why exactly we need that in the software development life cycle? Anyone? Maybe you can write in the chat.
Yeah,
Oh, cool. Yeah,
yeah, I can give a try actually.
please,
So
please.
basically, design patterns are used to tackle the problems that occurs, I mean, frequently in a particular manner.
Hmm. Yeah.
Yeah,
You're
that's what.
absolutely correct. Yeah, yeah, yeah. So, yeah, yeah. If we go and see, the Wikipedia's definition, that would say that a software design pattern is a generally reusable solution to the commonly occurring problem with a given context. So, it's a, I heard many times by my senior saying that most of the problems that you face in design in your application, right? They are already dealt with someone or somewhere in the history. So that is the reason we always have. It's not always that you will be whatever the issues that you're facing are the new and you are the only one. So those might be the very common and has been faced by many. So for few of the known issues, we have something called design patterns, and that is what it means. And also for few people call it saying that these are the best practices adapted by the experienced developers. That is also one of the definition for design pattern. Uh, in an essence, we have, uh, we are not introducing any sort of an algorithm or something, because if you go to any DSA or something, there's a definite way, there is a algorithm, there's a data structure which is known for this kind of problem. But coming to the design patterns, there is no definite solution for it. It's just to you're reorganizing your data structures, sorry, your code properly, so that it will be long lasting. Okay, so that's a simple definition from my side. And I think there are somewhere around 20 to 23 standard design patterns. And they are, I think, broadly classified into these three types. That is a creational design pattern, structural design pattern, and behavioral design pattern. I think my previous session was on factory pattern, which is, I think, creational, I guess. And today, I think we are going to look into strategy, which will fall again. I think, yeah, behavioral, I guess. Yeah. So these are the 23 design patterns. Okay. Ah, yep. I was correct. It's a behavioral design pattern. And let's quickly go into the very the heart of this session, that is the strategy design pattern. Okay, so by definition, this is the bookish definition that you can find it anywhere on the internet, and that is a strategy design pattern, and also known as the policy pattern, is a behavioral software design pattern that enables selecting an algorithm at runtime. Okay, so what it basically means is, well, algorithm is nothing but a set of instructions, okay, which will be given to solve any sort of a problem. But usually it's not such a, such a privilege that you'll always have this selecting of an algorithm during the runtime. Well, basically it says that you're trying to select an algorithm dynamically without any human intervention. So that's how your code should be written so smartly that given a sort of a problem or sort of situation, dynamically it should select from n number of algorithms which have been coded inside. Okay, so instead of implementing a single algorithm directly, the code receives a runtime instructions as in to which in the family of algorithms to be used. So it's more of a like you have to write a family of algorithms, and then you have to write on top of that which will be taking it dynamically. Okay. Well, yeah, let me see. Yeah. Before going to the overview, what I personally feel is what is the intent for it? Um, well, the intent is again the same. A pattern that lets you define a family of algorithms to put each of them into separate class and make them their objects interchangeable. Okay, so I think I just described the entire overview of the strategy pattern in this one thing. So let's take a look. Can you guys see this image, or is it blurry for you? Is this image fine?
Yeah, it is clear enough, I guess. Yeah.
Okay, okay, perfect, perfect. That's clear enough. Okay. Okay, let's take a quick look. Hmm. Or can anyone wants to take a guess what exactly this image is talking about, or anything? Um. Okay. Okay. So, well, basically, as I just explained that we will be having a family of algorithms. We have like maybe n algorithms, and then dynamically you'll be choosing one. That's the simplest thing. And here, if you see, you have strategy one, strategy two. So these are different separate classes, and then this particular interface would be, dynamically telling you what kind of an algorithm you have to induce. So all you're going to say is like, strategy dot algorithm based upon the parameters, dynamically it will call whatever you want. Okay, so that's about it. Probably I'll explain more with this with an example. So I'm going to talk about a very, very, much known example. Uh, well, it's called the duck applications. Okay, let's assume that we have, give me 1 minute. Okay. Okay. Let me share again my screen, please. Yes. Oh, okay, okay. So let's design a duck application. Okay, let's assume that currently what you're going to do is you have this one of an application where you're going to take a name and a weight of a duck, and then you have two different types of duck, that is loud duck and a gentle duck. Okay, and in turn the loud duck again have a different kinds of duck, let's say maybe village duck or city duck and maybe a toy duck. Okay, so loud duck basically means that it always, whenever you call that particular duck, it will say that it will might say that hello, I am duck 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 or something like that, which talks a lot. And the gentle duck is a duck which maybe not be that much interactive and a bit of introvert. It will not say quack quack or something like that. Okay, and then we'll have one more subtype. Let's take a city duck as a gentle duck. Okay, let's have this kind of a duck at the moment. And let me share my screen so that I'll just start coding it. Waiting in the room, let me add it.
Anupama, if you don't mind, can you give me an example? I mean, where we use in our real-time software
Mhm.
design this pattern?
Yes, sir. First of all, I'm going to tell you a real-time application or scenario, and then I'll pinpoint what is an issue with there, and then I'll tell you how you can implement this strategy pattern there. Is
Okay.
is that fine?
Yeah, makes sense. Yeah, thanks.
Yeah, makes sense. Because to know where exactly we use it, first we need to know what is the problem that we are facing so far to have this
Exactly.
particular design pattern, correct? So
Correct. Correct.
let
Yeah.
me, let me just share my screen. Mm, 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 file, just right there. Okay, stop sharing. Okay, can you guys see my screen at the moment? I think I am sharing my VS Code, and let me just, is this font enough or shall I just increase the font?
Yeah, I think this is yeah.
Yeah, that's good enough. Cool. Okay, let me just delete all this. This is not required. And yes, as I just discussed it, that we will be talking about duck application, correct? And I just defined few of the ducks. So let's start our basic duck. Okay, and then we'll have the init function for it. Okay, we'll have self, and as I said, it will be taking a name and a weight, and then we'll be calling self dot name equals to the name, and then self dot weight equals to weight. So this is the most basic constructor that I just created for the duck. Okay, and now I'm going to talk about, like I just said, that we'll be having two ducks. That is a loud duck, and then this loud duck basically always says quack quack whenever you click or you call this particular thing. It'll always say quack quack. I'm here. Okay, and then the gentle duck doesn't do anything. The gentle one is basically a very silent one. Gentle duck probably just say that I'm here. That's it. Cool. And let me just comment this. So currently our application is supporting these two kinds of ducks. So let's just quickly go ahead and create these two. Class called loud duck will be having def quack. I will be just copy pasting. And here I am going to show you an example of inheritance. So since the loud duck is a type of a duck, basically, so I will be inheriting this. So by writing this duck here inside the parenthesis, that's how we implement the inheritance in Python. And by writing this, what it basically essentially do is whatever the methods and the members are there in this main class will be accessible via this class too. So let's assume that we'll have a other call um, default call or something. Okay, and let's say self and then friend. Oh, let me just do quack again. That's better. Yeah. Let's assume that if this particular loud duck is doesn't quack or something, I mean it is not something special and it's just to the regular thing, then we don't even have to write this particular method over here because we already have a quack over here, so which will do the work. So tomorrow, if I mean further in the program, if you create an instant of this particular loud duck, and then if you say loud duck dot quack, it'll not throw you an error, and yet it will work because we have inherited this particular class from the duck class. Is everyone clear about the example which I just spoke, guys?
Yeah, it makes sense. Yeah.
It makes sense. Cool. So that's the inheritance, and let's go ahead and I'll be creating one more class, that is the gentle class, gentle duck. Okay, again, let me just this, and I'll be, oh, let me just write this, def quack again self print I'm here. Okay, so these are the major two things, and let's introduce more types. Let's, maybe I just explained it. Let's have some village duck, toy duck, and other ducks. Okay, I will just write different types of ducks. Hmm, class village duck. Okay, and I said that we will be having this guy particularly into this. That's inheritance. Def. We'll say go home. So basically, this particular method defines that how exactly will it go home. It'll print that I go to my home via river. Okay, since that's a village duck, and let's introduce a city duck. Duck, and say that I go my home via road, and then I have a toy duck too. Okay. Mm, duck. Okay. I think I'll make the toy duck is a class of gentle duck. Cool. So up till this point, I hope you guys are clear that I have majorly two kinds of duck in my application. On click of the loud duck, it will print quack, I'm here, and the gentleman just say I'm here. And on top of that, we have introduced two more varieties to our application. On click of the village duck, this is what is going to call, and on click of the city duck, this is what he's going to call. Okay, so I'll just mean what exactly that is probably if tomorrow I come here and I'll create a duck class as mm, 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 no, if I just create this class into a village duck, okay, and I'll say the name of it is um d duck, and the weight of this is going to be 10. Okay, and tomorrow if I just call duck dot quack, any guesses what it will print, guys? If I execute this code at this moment, what will happen? Will it execute or will it throw an error? What is it?
Yeah, you will get a quack. I am here.
The great. It will say quack I'm here, and if I do d dot go home, I think it will print I go to my home via river. I hope you understand why the d dot quack will work, even though it doesn't have a quack function in this class, but it have a function in the loud, which is inheritance. With that, we'll print it. Okay, I'll just run the code quickly. Okay, see, I hope you guys can see in my output, it's saying both the things as Ryan just said that, correct? Okay. Perfect. That about it. And moving ahead, let's imagine one of our clients is saying that in respect to all these things, we need to have one more duck called robot duck. Okay. And this robot duck can be a type of a loud duck, and it needs to have a new type of a method where where uh, where it can have a different feature. For example, maybe lights. A robot can have lights. Okay, let's say that we have I'm writing here, introducing new duck. Okay, having lights on. Oh, my bad. I think I did not implement here. Will be on for some time. Yeah, lights on method. Okay. So having said this, what exactly this basically new duck is going to do is it's going to light on. Okay. And then it will be telling how it goes home. And it is also going to have a new feature called play. So these are the new requirements for us to have to introduce a new duck. Okay. And they are going to call it as a robot duck. Any suggestion, guys, how we can achieve a new duck having these three features? Any guesses?
But there is a confusion here, right? So
Yeah.
these three methods are fine.
Mm.
But what about the other methods? Does it quack or does it go home?
Mm. Well,
Or does it
basically, mhm.
is it a type of gentle duck or it is type of a loud duck?
Okay, let's say that if you want those, I'll say it's a loud duck. It's a type of a loud duck. Okay, that's a good question. That's a type of loud duck. Okay, and it might just say quack, quack, two times quack, quack, and then say I am a robot. Yeah, so I just included whatever you want. So it's going to have a lights on feature. Okay, the lights on feature would be differing. So the toy deck lights on feature would be saying wait, will be here for some time, and this lights on feature might say that turned on for 10 minutes. So this when this application's robot ducks light on, when you slide on, this is what is going to print. And how is going to go home? It will have something else, play, it will have a play, and then loud duck, and it's a quack quack. Okay, this is all it is. Now, can you suggest how will you implement?
Then we can create a robo or duck class out of loud duck.
Mm-hmm.
And quack method, we can update it with this new double time quack quack.
Mm-hmm. Okay.
And the remaining else, the lights on method we have to implement, and go home we have to implement, and a new
Mm-hmm.
method called play we have to implement.
Mm-hmm. Okay. So let's assume that tomorrow you'll be having one more duck. Okay. It's called Daddy Robot Duck. Okay. And then say for 20 minutes, and then it doesn't go home, and it doesn't play, and it doesn't quack because I am a daddy robot. Now, any guesses, guys? How are you going to introduce the second type of a new duck, which is a daddy robot duck? Again, the same, guys?
Mm, yeah, maybe. I mean, we can have a generic class or a method which will take these parameters, and from that we need to create this new duck.
Exactly. So basically, I hope you understand here the problem is that
Yeah.
the behaviors could be differing. Okay? Maybe because of that, whenever there is a new thing that's coming in, always you're using inheritance. So essentially here you're just using inheritance and a bit of polymorphism where you have the same methods, but they have a different body and the things. Okay? So, yeah, the simplest answer is always you can create a new method. You can override with a loud and maybe gentle, or maybe the duck itself, and then you can write your own methods. But I feel that's going to be very complex. So let's assume that right now you have only this 4 to 5 ducks, and tomorrow this duck number of types of ducks could be increasing to 150 or 200. And there's a new developer who has just joined the team. He's really not aware of what to do. Probably he might create a new ones, or probably he might touch something in the very parent duck, that is in the class duck, and change something, maybe rename this or remove this, assuming that it's not been used or somewhere, or maybe introduce a new one which is already existing. So all these kind of issues would be arising if you have a lot of these kind of a nested inheritance, is what you can call it. Okay. So any guesses how we can help this out? I think one of the thing what he said is that probably we can have a generic method and then that can take care of it. Any guesses how we can use inheritance and so not inheritance, strategy pattern in this particular problem? Anyone? Let me just get down the definition of inheritance so that it'll be easy. Inheritance. Oh, not inheritance. Strategy patterns. So this is a definition of a strategy pattern that enables the selection of an algorithm at the runtime. So I think the simplest way what you can do is you can remove these particular methods and have the behaviors. Okay, so I hope you can understand that the lights on method was there in toy duck, but it was never there in the gentle duck. So even if you're going to create a new duck, a robot duck or a daddy robot duck with the help of this gentle duck, you can never inherit that particular sort of a behavior, but rather you need to create a new class and you need to have your own implementation. Okay, let's assume that tomorrow you have one more duck. Okay, let me just copy paste this and let's say this is a ABC duck. And let's say that it will be as same as the same lights on. It should be printing the same thing. So if we go with our previous approach where we are again creating a new class object for the ABC duck, it will have the same definition, which is the lights on definition. Correct? Is Are you guys following me? Maybe you can just type out in the chat. Hmm. Okay, cool. Okay. So the one more problem with this is probably if you create a new ABC duck, which is also very much similar to, the toy duck. I'll just create an ABC, is that we have this duplicate code. And tomorrow, if you're going to create a similar ABC duck with this kind of a thing, I go via road, again you have a two chunks of code which is repetitive itself, that is the lights on and the go home. Probably if you would have had a common thing or something else, maybe if this both the two methods were there in generic duck or something, that would be more simple. So I think one of the way, rather than directly jumping into strategy pattern, is you have a third kind of a duck, and if you have inherited that duck, you don't even have to write this thing. So that is one of the answer, how you can remove all this complex sort of objects, creating always and going only on inheritance. So this kind of a issue we encounter only if you're relying on only on inheritance and nothing else. So let me just quickly change this code into strategy pattern. Okay, so basically strategy pattern, it always says that you need to take one of the algorithm from the family of algorithms during runtime. So the reason what it is causing over here is always the behavior, this lights on, go home, and all these things. So what we're going to do is we are going to take these things out of classes. Okay, so we'll create mm, let me create strategies. Let me just create two new strategies. That is, mhm, hmm, mm, mm, or something. Save. Let me just save on the desktop and then save. Save level as this one. exactly is this? Um, Give me a moment, guys. This is irritating. This is not working. Give me a moment. I have a new thing, and let me just create a strategy.py. Now what I'm doing is I'm dividing the code. I'm not having all my code base into one file. Rather, I am bifurcating the entire behaviors and introducing a strategy pattern by having a new file called strategy. This is a one place where you'll be having all your strategies in place. Okay. As I just said that I'll be removing all the behavior, and I'll be having, let's say, class, maybe duck strategy. Okay, and then this will have a def quack, which is the most basic thing because these are all ducks, they always do quack quack. And I'll just just say that not much but a required method always. And moving ahead, let me just quickly implement few of the strategies. That is class loud loud quack strategy. And then this, here we're going to have a inheritance, and this is going to be a part of this. Okay, and then say def quack is self dot print. I'll just copy paste the code from the previous. That is the now guy would be calling this. Now I'll be having a gentle class. I'll just copy paste the entire class module over here. Call it gentle. And then it's going to just say I am here. Okay, and then for this, the ABC, the go home and the lights on, probably I'll just create another strategy calling, I'll just update this in. See. Does anyone have any doubt? Turn on for 10 minutes. Just turn on for 20 minutes. This guys will be having a light strategy, and then he will be saying lights would be on for 10 minutes. And here is going to be turned on for 20 minutes. Okay, any questions so far? I think someone wrote anything in the chat. No, cool. Okay. Does anyone have any questions regarding this particular, what I can say? This particular strategy or anything like that, guys? Why exactly, or any questions regarding the strategy class? Is it clear what I have done from this particular example to this particular example? Mhm. Doubts? If not, because I'll be going ahead and talking exactly what I can do with and how I can implement, how I am going to refactor the entire this code base using this particular strategy. That will be the second part of this coding. Okay. So if you guys are clear, I'll just repeat myself that we have a new called quack strategy. It have the by default method, and then I have this loud strategy and the gentle one, and then again light is turned on for 10, light is turned on for 20. Okay, and how we're going to implement this into our particular example is this way. First of all, let's have some importing, because we need to import. Or let me just write the classes first of all, that's better. Loud quack. So this particular loud quack defines this particular behavior here on this one, which is I'm highlighting. Similarly, we are going to have a gentle quack, which will be representing this particular kind of a behavior. And then I will be having a 10 seconds on 10 seconds on light, 10 seconds on thing. And that would be probably defining this kind of a method over here. Okay, and how exactly we can have all these methods into this particular classes is with a simple import. So I'm going to call strategy from the strategy import. Okay, my bad, I think this I am going to call this guy. There'll be a few copy pasting guys. Okay, and similarly here I'm going to just say gentle. And yeah, as simple as that. Again, just instantiating these particular methods over here with functional curly braces that will create an instance of that and would be saved over here. So with this, what we're going to do is we have all these particular strategies instances into this particular variables. Okay. So moving ahead, what I'm going to do is simply create again the classes as I have created earlier. Okay. The class, def, weight and everything is still the same, but except you're going to also tell what kind of a thing it is. I'm just reusing my earlier code by allowing it to pass the type of a strategies by the, like with the name and the weight and everything. With that, I'm also going to say, please tell me what kind of a duck it is going to be. Okay. So having said that, what I'm going to do is here I'm going to say the quack strategy and also the lights on strategy. So I'm going to just reassign the same thing with this. Self dot light strategy is going to be called with this. Later on, what I'm going to do is def quack self, and during that time, all I'm just going to do is I'm going to call dot quack. I hope you understand what exactly I'm doing. So I'm while I'm creating an instance of the duck, at the same time I'm taking the behaviors of them as a parameters, and later on, since all this kind of strategies would be here, I'm going to just do quack. So let's assume that the maybe the village duck was strategized and it was giving in a loud the loud strategy as a parameter. When you're going to do a quack, it's going to print quack, I'm here. And if you have a gentle duck, by initializing you pass on a gentle quack, that will printing I am here. And that's how you are not actually hard coding any sort of a quack into any of the ducks, like as we have done earlier. Here in the in the loud duck you're writing all this, and in the gentle duck you're actually writing all this, but rather that is there as part of strategy. And one duck can be can have more behaviors. So I'll just explain about the light duck and the robot ones, how exactly, introducing a new ones will not mess up the existing ones. by completing this class. Give me one moment. Probably I think I need to write one more and then lights on one. Self again, it will be the same dot. Okay, I think my bad. Here I need to write. I think I copy pasted it. Here. This is good. So now whoever is the duck is, whenever if they are creating for 10 seconds on, if they are passing this particular as parameter, this will be getting executed, and if they are passing this as a parameter, this will be getting executed. Okay, so that's pretty much the basic duck is having. Uh, I'll just instantiate one of the types, that is the class village. Can I maybe copy paste it? Just copy paste. Village duck is a type of duck. And then I hope you guys can see the understanding what I just did. Earlier, the village duck was a type of a loud duck, and the loud was not exactly a type, it was a behavior of it. Okay. So you were creating this as part of this via inheritance. Right now, you have removed that barrier. You're not dependent upon a duck's behavior anymore. Now you're just going to the main thing. You're just referring to the duck. So that's the point number one, that you can have it via inheritance, or maybe you can say inheritance in a strategy pattern. You still have inheritance, but it's not tightly coupled. It's very loosely coupled. And I need to write a def in it. So I need to write a super and then village. Self. I'm going to just call it self dot init of that and say it's allowed to quack and null. It doesn't have it doesn't have a light strategy. So I'm just going to pass none. So in the init, what it's going to create is a type of a village duck, but you know, since it's super, it's going to call this basically this init guy, and there you're going to pass all this particular strategies. Okay. And then I'm just say I go home via river. Okay. So let me just execute this quick small thing. I think I can still do this. Mm, okay, so let's call this thing quack. It'll just do quack quack and then go home. We'll call that. Quack strategy, and that is missing. Did I miss anything anywhere? Okay.
You did a mistake at line number 79, I guess.
79.
While yeah, I
Okay.
think that is where it is saying, I mean, complaining about, right?
I think yes. I think I missed out somewhere anything. Give me a moment. I'm just going through the code quickly. I'm not sure why exactly it is. Maybe two init pair. Oh yeah, I think I removed them just now. One person was given three. Did I mistake, or maybe let me just create a new village tab. Uh, init, love quack, and none.
Yeah, exactly. Actually, see, village duck init method doesn't have any parameters. It's only self.
Yeah, I
Okay.
think that is still fine, correct? Don't you think so?
Yeah, that should be fine. Takes one optional argument, but three were given.
Now two are missing. It is saying the quack strategy. Maybe did I import it correctly? Is what
No,
my
no, no. Because
question.
see, I mean, you are inheriting duck, right? For village duck, duck
Yeah,
requires
yeah.
three other parameters. So we are not
Ah,
passing
my
that,
bad,
right?
my bad, my bad. Yeah, I think. Give me a moment. I think this is fixed. Yeah. I need to remove this, guys. Give me a moment. I just copy pasted the code right here. Yeah, it's working. My bad. If I'm having all these guys also, probably I was supposed to pass, but I forgot. I will be having a name and weight over here too. Yes, I need to pass those two also, which will do the work. So let me just call old duck and 10 again. That's my bad, guys. Run. Yeah, see, it's working right now. It's the same code, it's just the parameters that have been messed up. So I hope you guys can understand how exactly we have implemented. I think someone just asked me, right? Earlier, the question was like how this can be included into anything. Did I answer your question, sir? Or I mean, I don't remember the name of.
But yeah, it's like, I mean, we are just avoiding this what is this complex inheritance here, right?
Yes, that's what it is saying. What we are doing is we always have to code not on the behavior but to the functionality of it. So coming to the earlier code, as you can see, when I said that we will be having these new things, saying lights on will be on for some time and 20 minutes and 10 minutes and then this all the behaviors of a duck. You really don't need to create a new class for that. And the problem is that I hope I told about inheritance. That we cannot have multiple inheritance at the moment. I think most of the languages are not supported to that. You cannot inherit multiple classes into one class. So that is the reason why we have, this other concept of interfaces or whatever that depends upon language to language is you can have multiple things. And how exactly strategy works is whatever the kind of a behavior that is, you need to segregate it out. You should never put all the behaviors or any sort of a things. So let's assume tomorrow if you have a car, correct? A car with two doors, a car with the four doors. If you take that particular example, you should never have a car with the two doors as one of an object, a car with the four doors as one of an object. That's basically just a behavior of it. A car is still a car. It will be still be going from source to destination, and it can be a slow and a fast car. But you should not be having a class called slow car, and you should not be having calling a fast car. Okay. Any more doubts, guys? Or shall I show you how exactly we can implement a robot duck with this example right now? I think it's pretty much just one liner call. That's it. We're just going to say robot duck, and then again you're going to have this name and it does have a quack, and then I'll be saying 10 seconds on. That's it. With that, if I have rd equals to robot duck uh, run, and then if I can call it the weight is 20. And if I call rd dot rd dot lights on, it will do the work. Rd dot quack quack, it will still do the quack. See, turn on for 10 minutes and the quack, here I am. So if it was not with this particular strategies, if you wouldn't have segregated all the strategies, probably you need to create two more methods and then you put in there. So that's the major difference between the generic normal code and having a design pattern in your code. Hmm. So I was maybe hoping we can have one more example. Are you guys interested, or do you guys have any questions regarding this particular duck strategy? Anyone have any questions?
No, this example looks good, but I'm still not able to understand, I mean, where we can use this in the real world actually.
Hmm.
Have you ever seen in the code, I mean, where this
Yes, I have
that,
implemented many a times.
like
Okay.
example, can you give me one
Um,
example?
okay, I can give you an example. So probably where I've used this code is, well, one of my previous organizations were about finance. It was for finance, and what I can give you the details is, okay, while creating an account, you can have different kinds of interest. Probably one kind of an account can have a simple interest, one kind of an account can have a compounding interest. Uh, is that a valid scenario, sir? Are you
Yeah,
following
well,
up with me?
yeah, yeah, yeah.
Yeah. So how exactly I have implemented strategy pattern in that particular problem statement was well, a user will just call, or not, when I say user, it's not actually end user, it's just the, the other developer who is going to come in the future. He's just going to call one method, he's going to pass some parameters, and then on top of that, all you have to just do is uh call it, like, I'll just write it on here, it'll be easy. Mm. Okay, so account, okay, and now this account can have two types of interest, that is compound, compound interest, and then simple interest. So while creating a new account, I am just going to say that this guy takes a simple interest guy. He is an SI guy, and then his name and basic details, age, vagara, and everything. And when tomorrow, if I need to create a new account, I'll be just saying, passing out his compound interest guy and the name and the age and everything. So when I want to know what is an interest or that is generating on this particular account, I am going to just say that, you know, ABC is the guy's name. And let's say this is XYZ is the guy's name. The requirement was whenever you call ABC dot uh, get interest, you need to get your particular output, saying maybe 100 rupees or something. Okay. And when I'll be calling XYZ dot get interest, this guy will be calling again, saying that 200, 300 rupees. So how exactly do you think we can solve this problem, Asif, if I pronounce your name correctly?
No, we can simply have a condition in the get interest method, right? In the get interest method, I can have I will check the account type. If it is
Hmm.
SI, I will do the,
Hmm.
I mean, simple interest calculation.
Yeah.
If it is CI type, I can do the compound interest calculation.
Very
But
good. And let's
uh,
assume, okay, that's, I totally understand. Like tomorrow, let's assume that we have some more interest types in the bank. Okay. Let's say maybe more 5 types of interest are been included to this list of these two. Again, what is your strategy? How are you going to include those new 5 types of interest?
yeah, even in that case also, I mean, even if you go with
Okay.
a strategy pattern also,
Yeah.
so you have something like multiple types of these accounts, right?
Yeah.
But also you have to modify the code to define a strategy for that particular type, right?
There is a difference. You're not going to modify any of the existing code. You're going to introduce the code, sir. So
Exactly, exactly. We're
yeah.
going to add a new strategy there.
Yeah, exactly. So now my point is there's two ways right now. You're saying that if there was only two, you would have put in a if and else wala branch and then you would have gone ahead. And now you're saying that if there were 5 more, you're saying that we would have modified the strategies particular here. Like this will be adding more classes, correct? Is my understanding correct?
Yeah, in the strategy pattern, we will
Yeah.
add more strategies
Yeah.
here.
So,
Okay. Mm.
okay. Yeah. Now coming to your question, sir, do you think if I add more new classes, let's assume that here I have more new classes, say, class vagera something, and I have one more class here and everything. By introducing this new class, do you think you will ever break any of the code with respect to these strategies?
I mean, yeah, I'm not touching that code, so
Yeah.
there is it is not. Yeah.
Yeah. And if we go with the option one where you have if and else condition, let's assume that in the nested if else condition, so that is the other option was like if else, correct? If it is SI or something, you do something. Else if, okay. Else if you have CI, you do something, correct? This is how you were expecting, correct, sir? Else if
No,
it's
I won't. I mean, I won't write the if else conditions here. Basically,
not here,
okay.
not here. In your
Na,
main code, whatever, when you are going to be calling get interest, here inside the get interest, you have this if else conditions, correct?
no, I mean, I would prefer. I mean, I may
Mm-hmm.
not be. I mean, modifying this one. Maybe I might be having a separate method or a
Mm-hmm.
class.
Mm-hmm.
Okay,
Mm-hmm.
which will take this type of the account,
Okay. Okay. And
and
give
based
you
on the
back.
type, yeah,
Okay.
I will get back the formula or whatever. I mean, the
Hmm.
compound interest, whatever it is.
How are we going to do that? That is, somewhere you need to have this SICI, the condition check to return the method or the formula also, correct? You need to have that equals to wala check, correct?
Exactly. Yeah. Yeah. Makes sense. Yeah. Correct.
If you're
Definitely,
going
I
for
have to have the
equals,
conditions.
yes, if it's not an if else branch, you're going to have a switch branch. Again, switch cases will also work the same. It will do the identically same thing, correct? But
But yeah,
somewhere you have
anyhow,
to
yeah,
introduce that.
yeah, we doesn't have in Python. We doesn't have this case, but yeah, makes sense.
Yeah, yeah.
I
Let's
think I
assume
got it.
that while you're executing that, some null pointer exception or some undefined exception is occurred in this else branch. What will happen? Or in that switch case, whatever your new generic method or get formula method, whatever the method you create, what do you think it will happen to the code?
Yeah, I got it.
Yeah. So answer to other questions. So
Yeah,
other
thanks.
guys, that if you don't have this, I mean, if any error occurs in this particular else if branch with some null pointer or anything, it will just blow up the entire application. You might have error, and you might see an error pop up in your final application thing. But whereas coming to this strategy pattern where you have the basic quack or the basic method out of which you are extending or implementing whatever you can say, and having these different strategies will help you to have a fallback mechanism. You even if you don't have a quack, even then with the lights on strategy guy will have a quack. Even if you don't write that method, the super class guy will have that method, and he will print or he will give you a generic one. So this way you can save it. So answer to your question, Azif, I guess it's not always important to implement a strategy pattern. Okay, I will discuss about that in the last slide of mine, which is where I'll be talking about the conclusion. But yes, whenever you think, like I said, an account is a type. The function of this account is a lot of things, and what kind of an interest that will be going on, that's a behavior of it. So again, this kind of a problem I could have solved in two different ways. One is by having a strategy pattern. Maybe I can be including a factory pattern over here and can discuss more further on that. But that's for some other day to have a discussion how you can write the same problem via a factory pattern. Okay. And this is how it was one of the issues. Uh, okay, yeah, that's about it. So that is how we are going to differentiate in a factory sorry in a strategy pattern where you're taking out the all the behaviors and having only the concrete objects there, not having relying on the behaviors for it. Because always a guy can have been pointing out to the one parent, not multiple inheritance. So that's the thing. um yeah, that's quite a bit. Let me just share back the original slideshow so that I can get to the closure of this thing. Okay. Okay, so here is the conclusion for this particular design pattern is that whenever, oh my God, my bad. Yeah. The point to separate an algorithm into different classes can be a pluggable in runtime. So let's assume that tomorrow you're not having one strategy and you'll be having different strategies. So you don't even have to change the code. You just have to rename the file name so that it will be, in taking input from that file, and it'll do the work for us. So I hope you guys are understanding. That is because in the earlier part of my code, you have seen that I have imported it from a different file. That is one of the reasons why it comes in handy is if tomorrow you have anything, just rename the file or, just call it from a different. So that's one thing. Second, one main class can use more than one strategies, which allows you to recombine them in a multiple ways. So in the robo example, we have implemented with a light and a loud and but not having multiple classes. So you have a lot of mix and match options. Third conclusion is that code is easy to maintain as modifying or understanding strategy does not require any understanding of the whole main program. So this is where the it comes very handy if you have a new people in your team, and if they are given some task and they don't have time to go through, they don't understand the entire code, which is still fine because you really don't have to touch the existing code. If you're not touching the existing codes, you're not going to introduce any new bugs in the existing code. That's how you save a lot of time. So if you're not touching the existing code, that means that you don't have to do all the test simulators or whatever you have, the automation testing units. You don't have to run all that into the code. Okay. And then but yeah, there's also only and one drawback to this is that this strategy is an overkill. So, like the earlier example, he said that probably we could have had an if else condition, would have done the work for the simple and compound interest case. But at times, it's not always an if else. If it is going beyond a limit, maybe beyond, I would say, 4 to 5 if else conditions also, that is the time where is a good time where you can go and implement this pattern. But if it's only between 1 to 3 or something, I would say it is better to go with a if else or a switch case. Okay, because handling 1 to 2 or 3 if else is way better. The moment it will go into 4 to 5, that's a complex code. Is what usually I have been learned in my this experience. So yeah, the drawback in the many cases is that it's an overkill. Consider starting with a simple control flow statements that's a switch on if else, and then only if it is necessary to move to the class hierarchy, then you can have it. So that's about the design pattern. Is anyone have any questions? Because we are left with I think 8 to 9 minutes, and I'm open for taking any questions.
Yeah, Anupama. I mean, I was thinking about the problem. I mean, this account problem, right?
Yeah.
So, I mean, how about this one? So, what I will do is I will create one account manager first.
Okay.
Okay. And after that, I will have a subclass for each account type. Okay. Simple interest account, compound interest account, XYZ interest account. Okay. In these classes, I will implement this get interest method or any XYZ method, whatever we want in each of these classes.
You said, give me
Okay.
one moment. I think I missed it. You said you'll create an account manager method, correct?
Yeah, account manager
Okay.
method.
Next, what you'll do?
Out of this, I will create subclasses like a simple interest account
Okay.
and similarly compound interest account.
Okay.
Okay.
Okay. Okay.
So while creating the object, so I will always be creating object via account manager.
Okay.
Okay, so while creating the object, I will pass the account type. Okay, so in the account manager, I will have that mechanism to call that particular class method. Okay, so does it call a strategy pattern or is it is something else?
Okay, so this is what you're saying, right? If you have something like this and else,
No, I need not to do something like this. Type CI is equal to no. I won't use
okay,
any conditions here. I
okay,
can directly create each instance. I mean, I can create an object, right, with the directly with the string as well.
Okay. But it's safer to have this thing because at times, what if you encounter any error? Have you thought about that?
No, see, no. In the see, basically we will be interacting through some user interfaces, right? UI.
Acha,
So
acha, acha, acha.
in the
Okay, let's
UI
assume that.
definitely,
Mm.
I will be having exact string whatever I want the class name.
Okay. So I think I can categorize that under. I mean, yes, you can do that. Like I said, that there is one more way of, addressing the same problem. That is the factory pattern. This is a factory pattern example.
Oh, okay. Yeah,
This is factory
got it.
pattern.
Yeah,
So
thanks.
factory pattern is a creational pattern. So this is how you differentiate. I explained you, right? There are three types of patterns. That is structural, behavioral, and creational. Behavioral is how it is acting. Creational is how you're creating it. You said, yes, I understand you will not have an if else conditions, but rather you will have the class name dot, you will be calling this, correct? This is how you're going to do this.
Yeah, correct. That is what
Correct.
I'm going to
So,
do.
yeah, basically, you will have a factory which will be creating on the go. So, that is actually an implementation of factory. So, the only difference between factory and strategy pattern is here you're actually writing an entire instance of that particular object or whatever you're creating in it. Correct class. But in strategy, you never written anything. None of this code is not written in. It is just written, you're just calling it, you're using it, you're not anyway, if you don't see written turn on 10 seconds or something like that. So that's the major difference between factory and strategy. There are so many instances that you can write factory also, and also you can write strategy also. It's the only matter of that what are you doing it. Are you just executing it, or you're written any methods? So what you just explained me is a classic example of factory pattern.
Yeah, thanks, Albama. That makes sense. Thank you so much.
That makes sense. Does anyone have any other doubt, guys? Maybe I can answer that too. Hmm. Hmm. I think we are open for next 5 minutes. I think someone just asked me about having interfaces in Python class, correct? As if is that you who asked me earlier?
Yeah, yeah. I mean, I was saying that there are no interfaces in Python, right?
Yes, you're actually sort of correct, because Python is it is an object-oriented programming language, but yet it is a bit a simpler version of that. You don't exactly have extents or implements like other, you know. You just have to pass, like even in the interest, you just pass it. So I think, as far as I am aware, how much code that I have written, how usually interfaces are written is you do have an interface actually, like a class is defined, dedicated new .py file, and then what you do is probably you can have a duck behavior interfaces, and then you can have all your interfaces here as dev, and then you pass it on. You write pass. So if I have something like this, go home or something, that is how you usually write, is what I'm aware of.
I think I have seen. I mean, in fact, I have written the code something like this. So, take the example
Yes.
of account manager. Okay,
Yeah,
in the
yeah.
account manager, I will have a get interest method, and I will have
Mm.
a not implemented exception there. So,
Exactly.
if the
Yeah.
child class doesn't implement that, I will throw the error.
Exactly. You're exactly correct. So what you basically, at least in Python, what you do is, if you really want to have that interface sort of a feeling to do some other pattern, or to make your code readable and extensible and all that thing. So what we do is we write a pass, and then the child classes will actually have this light methods implementation depending upon it, or whatever that is. That's how you have interfaces. I mean, they don't exactly implement or extend, but yet that's how you can do it. And probably one of the reasons why you can have is, and also we can have this those meta classes. Have you heard of meta classes? Even they can do a bit of work for us. I think all these are meta classes, right? Under init and under things, these are all meta classes, correct? Even via them you can have a quick check whether this function is present, or that method is present. So yeah, answer to your earlier question. I think yeah, that's it. Okay, guys, so with this example, I think we have reached to the end of our session, where we have discussed about the design pattern, strategy pattern, how it is, what it is, and a quick class diagram. And we have seen the code without how it is written, and how we face trouble to introduce new objects when you are tightly coupled the inheritance to its behavior. It will do a chaos programming by introducing a lot of objects, and via strategy pattern, when you decouple the objects, or the main things with respect to its behavior, that would be simple. And then all we just have to concentrate on the concrete classes rather than the behavioral of it, and then that would be quick and simple. And at the end, thanks to Atif, I think I was also able to give an example where you can have this one particular example written in another way with another pattern, that is factory pattern. Well, the factory pattern basically returns a object instance, and strategy never returns any instance. It just implements. It's an algorithm. It works with the algorithm. And whereas the factory is a creational or design pattern which always returns anything. It doesn't work. It doesn't execute. It just returns. And whereas strategy will execute the things for us. So with that, I think that's the end of the session. Thank you, everyone. It's been amazing. Thank you for making it a, such an interactive and asking questions. And it was a very quick and short session. Thank you so much, guys.
Yeah, thanks. Bye bye.
Thanks. Bye, guys.